Good day to you. This is teacher Leland, Alejandro, and we're going to discuss today Radian Measure. The Radian Measure is another unit of angular measurement, and an angular measurement unit. So the commonly used is the degrees. So we will have degrees and radians and vice versa. Okay, we will do conversions from each unit to the other. So let us see the problem set that we're going to use. To the other screen. Okay, here is the first number, but let us see the total first. So let us have the total number. So we have about 14 there, 14. Okay, so we have the first part, conversion from degrees to radians, and then the second part is conversion from radian measure to degrees. And then, so first part is degrees to radians, and then second part is radians to degrees. And then the last part is something about worded problems. Arcs, central angles, and radius. Okay, it's something to do with those variables. So we're going to solve one by one from the first number. We will have the presentation view. So the first one is convert each degree measure into radians. So first we will see the conversion factors, and we have 180 degrees. 180 degrees is equivalent to pi. So that is, and then 0 there. All right, pi radians there. Now pi radians is equivalent to 3.14. So this is the same as 180 degrees. This is equivalent to 3.141592654 radians. There. Okay, this will be used in converting from degrees to radians, also from radians to degrees. Okay, so let us make use of the first problem, convert each degree measure into radians. So we will start with the solution. We have the solution, and the given is 240. So this is 40 degrees, 240 degrees. Okay, so conversion goes like this. So we start with 240 and then write the unit, and then this will be multiplied. Okay, so times, let's just use the asterisk there. And then we make use of, all right, the pi radians on top. Okay, so this will be pi radians per 180 degrees there. Okay, and then we put some line at the bottom. That is a fraction. Okay, like that. And we can make that smaller. So we can select this. Okay, and we have here 240 degrees times pi radians. This will have a unit, of course. This is radians. Let's abbreviate that to radians like this. So you can see here degrees and degrees cancels out like that. There. And this will now be equal to the numbers 240 times pi. The next line will be 240 and then times pi, right? So that would be 03A0 of x, and then that's a Unicode actually, and this is times pi, and then this will be over 180 like this. Then we put the line for the fraction, okay, and since we canceled already the degrees and degrees, this is now in radians, so the unit of this is already in radians like that. Okay, so we can get the the factors and then make the numbers smaller. So we can have it like 24 times 10, okay, like this. And then the pi, okay, and the pi is there, and then this will be, of course, divided by, this will be divided by 18 times 10, okay. So we can write at the denominator, we have 18 times 10, the factors of 180. Then we can now cancel out something. We can cancel the 10, like that. And we're down to 24. Okay, we're down to 24 times the pi over 18. Okay, this is over 18, like that. And the numbers are smaller at this point. And we can still reduce this to get the simplest answer. 24 is 6 times 4. Okay, so we can continue with the factors. We have 6 times 4 times the pi. Okay, so that's and then this is divided by 18. That's also 6 times 3. Okay, so 6 times 3. So we can have 6 times 3, and then we have our new fraction, and we can start canceling the numbers. Okay, the 6. Okay, we can cancel out the numbers. Cancel the 6. Cancel the 6. And we have, finally, we have the answer. That's 4 pi over 3. So our final answer, this is equal to 4 pi over 3. So that's 4 and then the pi. 4 pi over 3. So this is the answer. All right, so that's it. This will now be in terms of pi. And we can encircle this. And this is in radians, of course. So the unit of this is radian measure. Yeah. And this is our final answer. There. Now, if you need the numbers, okay, the equivalent of 4 pi over 3 radians, okay, you can actually convert this into something like decimals, okay. Now, I will put that over here. Okay, so coming from 4 pi, okay, from 4 and then pi, so that's 0, 3, a 0. Let me retype that. This is now 4, and then we have the code there. There. All right, 4 pi and then over 3, of course. This is 3 at the bottom. You can convert this. This is equivalent to something like, we put the equals here, and then we put the numbers 4 times the quantity, the equivalent of pi, which is 3.151592654. That's the equivalent of pi. And then this is divided by 3. There. And then we put the long underline. Okay. And then we shall calculate this. Okay. All right. So let's get our scientific calculator and compute the angular measure in radians. All right. So this will be in decimals. So this is just 4 times pi over 3. And that's equivalent to 4.18. Okay. So we can type the entire number there. This equivalent to all right, 4.1887902.05, and this is radians. There. Okay, this is the equivalent in decimals. Okay, so 4 pi over 3. And this is the equivalent of 4 pi over 3. It's 4.2, okay? If you're going to round it in the nearest tenth, okay? 4.2 radians. All right, so let us see the computer's answer in terms of pi. There, it's 4 pi over 3, okay? 4 pi over 3, exactly what we have over here. There. So I just demonstrated how you can get the answer in decimals, okay, over here. If you want to get the answer in decimals, so it's 4.188790205 radians, accurate to 9 decimal places, okay? All right, so if you want it in decimals, then you can do you can use the actual value of pi, which is 3.141592654. Okay, so the computer's answer is over here, which matches our answer. It's over here. There. All right, so that should be for our first number. Let's continue with the next. Let's have the next number. All right, so here's number 2. Convert each degree measure into radians. Convert each degree measure into radians. All right, let's start with our solution. Okay, we have the given. The given is 405 degrees. Yeah. Okay, so we're going to solve 405 degrees. Let's abbreviate that this way. And then this is times the quantity. All right, we will start with the pi on top. Okay, so this will be the pi on top. All right, so probably we can just copy that for future paste. All right, so that's 405 degrees. And this is now pi radians. And we're going to abbreviate that as well. Pi radians for every 180 degrees, just like from number 1. And this is now the conversion factor. Pi radians for every 180 degrees, okay? So you put the 180 degrees at the denominator so that the degrees cancels out with the degrees there, okay? And you will now be left with a unit in radians. So this will now be equal to 405 times pi, okay? Times pi there, and then over 180 there. And this is now in radians. After we simplify the fraction, okay? The unit of this is radians. There. So 405 pi over 180. Now, we can do some factoring here. So this is divisible by 5, yes. So 405 is about 81 times 5, yes. You can get 81 times 5. That's 405, okay. And then we have the pi. And then 180 is 36 times 5. 36 times 5, there. We're getting the factor so we can make our numbers smaller. Now, the 5 and the other 5 cancels out, okay? All right, so the next will now be 81. We will just have 81 and the pi and the 36 there. This will still be in radian, of course. So 81, we can get the factors, okay? We have something like 9 and 9, and 36 is 9 and 4. So we can get all the factors so that we will have the final answer, and the fraction will be in the lowest term. So 9 times 9 times the pi, and the bottom is 9 times 4. That's for 36. And you see the 9 cancels out with the 9, okay? You can cancel out the 9 here. Cancels out And we will have our final answer 9 pi over 4. So this will be 9 and then pi over 4 there. And this will have to be in radians. So this is now in radians. Okay, so this will be, of course, a fraction. So 9 pi is at the numerator and the 4 will be at the denominator. And this is the final answer there. Okay, so over here. All right, so we can verify this from our computer. Here, it's 9 pi over 4 radians. Okay, again, if you want to see the equivalent in decimals, then we can actually do that. We can actually do that in the remaining space here. All right, so we have 9 pi over 4. Okay, 9 pi over 4, and this is in radians. Now let's see how to get the equivalent in decimals. All right, so this will be equals, and then we have the 9 there. 9 times pi, that's 9 pi. So that means 9 times 3.14592654, the equivalent of pi. Okay, and this divided by 4, like this. So these are now pure numbers. All you need to do is multiply the 9 and the 3.14, and then divide the result by 4, and we have the answer. Okay, so this will be equal to, let's compute. So we have there 9 times pi divided by 4. Okay, and that should be 7.06. So this is 7.068583.471. And this will now be in radians. Okay, this is in radians. There. So the 9 pi over 4, that's equivalent to 7.068583.471 radians in decimals. Okay. All right. So that is if you need the actual numbers. Okay, equivalent to 9 pi over 4. Okay, but the computer also just requires only, it only requires this type of presentation of the answer here. So we're done from here already. There. Okay. All right, let's continue with number 3. All right, so in the third and fourth and fifth number, we will not be computing it in decimals. Okay. All right, so at least you know how to do it over here. Okay. All right, there. So you know how to do it over there. All right, so let's continue with the third. Let me clear the screen. And we're going to do number 3. Okay, here's number 3. Convert each degree measure into radians. Okay, this is 30 degrees. It's a special angle. It's a special angle. I already know the answer. It's pi over 6. Okay, because that's the sixth part of half circle. Okay, all right. So it's simply 180. Okay, divided to 6 parts. Okay, all right. That's 30 degrees. All right, so in radians, this is pi over 6. All right, but then let us show the solution. Okay, let's have the solution there. The given is 30 degrees to be converted to radians. Okay, to be converted to radians. So this is convert to radians. Okay, convert to radians. All right. So we start with 30 and then put degrees. Okay, and then this is times. Okay, we have the equivalent pi over 180. For every pi radians, that's 100. There are 180 degrees. Okay, there. Okay, so this is our conversion factor right there. Okay, so you can see degrees cancels out with degrees, and we're left with 30. And we have times pi, and then divided by 180 there. and this must be in radians. Yeah. Okay. All right. So we can actually see this way, and you can see the 180 there. That's equivalent to 6 times 30. Okay. 6 times 30 is 180. So we can actually get the factors of 180, and we can start canceling the numbers. So this is 30 times pi. We can put it this way, and then we can get the factors of 180, which is 30, okay, times 6. Okay, there. 30 times 6 is 180. All right, and so we have the two numbers 30. You can see the two numbers 30 cancels out, and this cancels out with this, and we're left with the answer pi over 6. Like what I said, it's pi over 6, and this will be radians. There. There. Okay, so pi radians, this is pi over 6 radians. So we can verify this from the computer. Okay, over here. There, it's pi over 6 over here. Here's the computer's answer from its database. So it's pi over 6, and that's in radians. Okay, all right. Next, we proceed to our fourth example. Let's continue with our fourth example. Okay, convert each degree measure into radians. We are given 10 degrees here. So the given is 10 degrees. Convert to radians. Okay, convert to radians. Yeah. All right. So solution goes this way. Start with given 10 degrees, and this is times pi radians. Pi radians. For every pi radians, there are 180 degrees. So we use pi over radians. For every 3.14 radians, there are 180 degrees. And see, this cancels out. The units, degrees and degrees cancels out. We're left with radians. And we can get the factors here. Okay, so the factors of the numbers. So we have here 10, and then the pi, and we have the 180. Okay, and this is now in just radians. There. Okay, but what are the factors of 10 and 180? So if you're going to factor this, this is 10 times 1 times pi. And below, you have 10 times 18. 10 times 18. Okay, those are the numbers for 180, and the numbers for 10. Okay, and we still have the fraction symbol over here. There, and you see the 10 cancels out with 10, and the final answer is 1 times pi over 18. So it's simply pi over 18. Okay, so the final answer is pi over 18. There, and this must be in radians, right? And then we put the fraction symbol there, and this is our final answer for number 4. Okay, check it out. What about the computer's answer? Pi over 18. Yes, so we're correct as verified over here. All right, so pi over 18 radians. Let's continue with number 5. Let's continue with the fifth number. Here's number 5. Convert each degree measure into radians. We have 75 degrees, the given. Okay, we have the given here. 75 degrees. There. And we're supposed to convert to radians. All right. Solution. We have 75 degrees times pi over 180. All right, so pi radians per 180 degrees. Yeah. Again, we use this conversion factor always when converting from degrees to radians. And we can see the degree unit cancels out with the degree over here. Yeah. Then we can start getting the numbers. We have here 75 and the pi and the 180, okay, like this. And the unit, of course, is now just radians. And we put the fraction symbol for there. But 75 over 180 can be reduced to lowest terms. So we can get the factors of 75. That will be about, how much is that? 5, 15, okay, 5, 15. All right. This is how to get the lowest term. 75 is 5 times 15, and 180 is 5 times 36. 5 times 36. There. Okay. Like this. Okay. Further, we can factor the 15 and the 36. So let's cancel out the numbers later. So let's continue getting the factors. 5 and then times 3 times 5. That takes care of the 15. This will still be there. Factors of 36 and the 5, you still have the 5. 36 is 3 times 12. 3 and 12. Okay, that takes care of the 36. There. Okay, let's start canceling numbers. We can cancel out 5 and then 5, 3 and then 3. Okay, we still have the pi over here, so let me insert the pi here. This is yes, we still have the pi here. Let me change this part here. Let me scratch this out. 5, 15. Okay, we have 5 and then 15 and pi. Let me complete my writings there. Radians, and then we have the 5 and 36 there. Yeah. I'm just rewriting it because I did not write the pi in the first place. All right, so that's it. And we shall put the pi over here too. Okay, we shall put the pi over here. Let me reconstruct this. Let me reconstruct this. This will now be, let me reconstruct that. This is supposed to be with 5 and then 3 and then the 5 and the pi there. Okay, like that. And of course we have 5 and then 3 and then the 12 there. Okay, that is now complete. All right, this is now like this, and then we can start canceling the numbers 5 and 5, 3 and 3, and we have our final answer 5 pi over 12 there. Okay, so we have a complete answer with the pi there over 12. Okay, this is of course in radians there, and we put the fraction symbol there. Okay, so this will describe our final answer expressed in pi. Okay, so this is 5 pi over 12 radians. Okay, all right, so we can verify that from the computer. There, it's 5 pi over 12. Okay, there. All right, so let's continue with number 6. I think that will now be radians to degrees. So we're done with degrees to radians. All right, so let us continue. Number 6 now. Here's number 6. Convert each radian measure into degrees. Okay, so this time it's the reverse. It's from radians to degrees. All right, so the given here is, of course, radians. Okay, so let's write first the given. The given is negative, and this is 29 pi, 29 pi over 36. Okay, and the unit here is radians. Okay, of course this is radians. The unit is there. Okay, so it's negative 29 pi over 36 radians. So those are the numbers, the negative, and then that negative symbol, and then the fraction 29 over 36 and the pi. And we know that pi has a value. Okay, so that's 3.14. Okay, so a reminder that pi is equal to 3.141592654. Okay, and this is radians there. Okay, so the equivalent in decimals. All right, so let's start with our solution. The solution will start from the given. We have here negative, and we put that fraction symbol right away. Let's put that fraction symbol there. And we have 29 pi, and that's over 36 there. Okay, so 29 pi over 36. So the unit here is radians. Our conversion factor now is slightly different. So this is now times, all right, this time the 180 must be on top. So it's 180 degrees for every pi radians there. Okay, you can see it over here. There. Okay, so from numbers 1 to 5, we used pi radians per 180 degrees. Okay, so in converting radians to degrees, we will have to invert that. We will have to use 180 degrees per pi radians. Okay, and you can see the radians symbol here. The radians unit cancels out there. Okay, also the pi cancels out, the pi and the pi there. All right, and so we now have just the numbers and the negative sign. So we have here negative, okay, and we have the numbers on top. Okay, we have 29 and 180. This will be, of course, 29 times 180, and this is now in degrees. Okay, like that, and this is divided by 36 there. So the numbers 29, 180, that belongs to the numerator. The 36 will be at the denominator. And then we can simplify the answer. All right, so we shall get the factors of 180. 29 has no other factor except 1 and itself. It's a prime number. So we're going to have here the negative, and then we shall continue with the 29. And then 180 can be factored 5 times 36, like that. And this in degrees. We have the 36 at the denominator there. Okay, so we have here the fraction symbol there. Okay, you can see the 36 cancels out with 36 there. And we have just the product of 29 and 5. That will be, how much is that? That will be 145, okay, 145. Yes, 145. So it's negative 145 degrees. There. It's a negative 145 degrees. And we can see the answer that can be verified by the computer. It's a negative angle in degrees. All right, let us verify there. You can see the answer near the given over here. it's negative 145 degrees. All right, that's for number 6. Let's continue with number 7. Let's clear the screen. Number 7 is over here. Okay, here's number 7. Convert each radian measure into degrees. So it's from radian to degree unit. All right, the given. Let us start with the given. Okay, the given is negative pi over 2. There, okay. And this is radian measure. There, okay. Supposed to be a fraction. There. Pi over 2 radians is the given. Okay. Solution is over here. We are converting to convert to degrees. Okay. Convert to degrees. There. Okay. And so our solution start with negative, and then this is pi over 2. Okay. This is radian measure. And then this will be multiplied by 180 degrees, okay, for every pi radians. There, okay. So this is our conversion factor. Okay, this is pi over 2, the given. This is our conversion factor, 180 degrees per pi radians. There. Okay, so you can see the writings. You can see the radians and radians cancels out. Okay, you can see this part here. Radians cancels out with radians. Also the numeric pi and the pi there. Okay, so what is now left is just the negative sign and 180, and this is now in degrees, and of course we still have the number 2 at the denominator there, and then we put the fraction symbol like that, and 180 divided by 2, that's 90 degrees. So final answer is a negative, that's a negative 90 degrees. Okay, there. This must be the answer. Okay. All right, so we can verify this from the computer. There, it's a negative 90 degrees. Okay. That answers our number 7. All right, let's continue with the next. Let's do number 8. Let's do number 8. Here's number 8. Convert each radian measure into degrees. We have 23 pi over 12. We start with given data. We have 23 pi. This is radians over 12. There. Okay, this is the given. All right, for our solution, this is conversion to degrees. Yeah. So our solution will start with 23 pi. This is radians. Okay, and this is over 12. So we start from the given, and then our conversion factor. This is our conversion factor. So times, okay, we now have the 180 on top, 180 degrees for every pi radians. There. This is our conversion factor. There. Okay. All right. And so you can see the pi and the pi cancels out. You can see this. This is a number, cancels out with this number. Also, the unit radians cancels out with the other unit radians there. And so we'll be left with the numbers 23 times 180. Okay, this is now just degrees. And this is divided by 12. there, like this, there. Okay, so what we need to do now is simplify the numbers. Okay, 23 is a prime. Now 180 is 36 times 5. All right, so we can now do our factoring. Let's do our factoring. All right, 23, 180 is expressible to 36 times 5. Okay, this will still be in degrees. Now 12 is just 12. All right, we don't have to break it because we can get the 36 later containing a 12. Okay, there. All right, we shall cancel out later. So there's no hurry. 23 and then 36 is equivalent to 12 times 3. 12 times 3, and we still have the 5 there. And then we now have the 12. We still have the 12 at the denominator. Now we can cancel out. Okay. All right, here. So this will now be canceling the 12. Okay. So we can cancel the 12. Okay. And we can now get the answers 23 by 15. And that's it. Okay. In degrees. All right. So this will now be just the product of 23 and the 15 there. Yes, there. This is now degrees. Okay, 23 times 15. And so this will be, we can now calculate that. So that's 23 by 15. That's 345 degrees. So this is 345 degrees. There, that's it. And we have a simpler solution. Okay, there. And then we can verify there. It's 345 degrees over here. You can see it below the given there. Okay, that's the computer's answer. You see, you have to click it here so that the computer shows the answer. I can make it disappear there. Okay, all right. So once you click it there, it shows the computer's answer. All right, and so that goes to our number 8. Let's continue with number 9. Let's have our number 9. Okay, here's number 9. All right, convert each radian measure into degrees. I remember pi over 6 is 30 degrees, okay? 30 degrees. So this must be negative 30 degrees. All right, so, but let us show the answer, the solution. Okay, we have here given, this is negative pi over 6 there, okay? And this must be radians. Okay, the unit of this is radians there. All right, how about the solution? This is converting to degrees, okay? Converting to degrees there. Okay, so for our solution, we start with the given. This is now pi over, all right, this is pi over 6. And this is negative, okay? Supposed to be negative. So we put a negative sign in front, and then we put the fraction symbol, okay? And the unit, of course, is radians, abbreviated RAD, and then we multiply this. Our conversion factor is, of course, times, we'll start with 180 degrees per 1 per pi, okay? Per pi radians. There. This is our conversion factor. There. Okay. All right. So we continue with our solution. Okay. The pi cancels out with the pi, and then radians cancels out with the radians at the denominator. All right. And so we're left with the unit degrees, and the remaining numbers. Okay. We have the negative sign is there. The 180 is there, and the unit is degrees. and this is over 6. There. This is now our unreduced fraction. Okay, there. Okay, and so 180 divided by 6, that's 30. So our final answer is negative 30. So this is negative 30 degrees. There. This is our answer. Okay. There. Okay. All right. Let us verify from the computer. Okay. There. You can see the answer. All right. There. It's negative 30 degrees. Let's continue with number 10. Continue with number 10. Okay. Let's continue with number 10. Here's number 10. Okay. 17 pi over 180. Let's write the given first. Convert each radian measure into degrees. So this is conversion. This is conversion from radians to degrees. There. Okay. Okay. We begin with the given. Okay. The given is 17 pi over 18. There. And the unit, of course, is radians. There, that's the given. It's a positive angle, okay? So our solution will start here. We have 17 pi over 18. This is in radians, okay? This is the given. Our conversion factor will be multiplied. So this is times 180 degrees per pi radians. There. Okay, and so we can now divide something. Okay, the pi divides by the pi. Also, the radian unit cancels out with the radian. Okay, and so we continue with the remaining numbers and unit. We have 17 times 180. This is now in degrees over 18, like that. 18 at the denominator. There. Okay, so we only need to simplify. 180 divides by 18. Result is 10. So we're going to have 17 times 10. So we are going to have 17 times 10. This is in degrees. And finally, we have 170 degrees. There. This should be the answer. The final answer is 170 degrees. There. Okay, so you can verify the answer. It's 170 degrees. Okay, so that goes to our number 10. Let's proceed to the problem solving. Okay, we're done with conversions. All right, let's have the next. Solve the following. Okay, 11. A circle has a central angle of 4 radians that intersects an arc of length 24 inches. Find the length of the radius r of the circle. Okay, so let us concentrate with the given first. Let's have the given first, so we can start here. Okay, what we have, central angle. So we can call that theta, all right? Or the symbol that we can use here, let us just use q, okay? Small q, like this, there, okay? And this is equal to 4 radians. There. What else do we have? That intersects an arc of length 24 inches. So it's a unit of length, arc. We usually use S, okay? And this is 24 inches. There. Okay. So the question is find the length of the radius. So we're looking for R. This is the question there. Okay. All right. The formula here is it's usually the arc S This is the formula. The arc S is equal to radius R times, okay, the central angle theta, okay, central angle theta. Now theta is a Greek letter. Now we shall replace that with a simpler alphabet Q there, okay. So this will be our working equation. Okay, this will be our working equation. Let's put it over here. All right. Okay, there. Okay. Okay. So formula is arc S is equal to radius R times central angle. Or in a simpler presentation, we can just use a simpler presentation. S is equal to R times Q. There. Okay. R times Q. All right. Okay. So we're solving for R here. Okay, so after doing literal equations, R is equal to S over Q. Okay, R is equal to S. Let's put it on top. That's S over Q. Yeah. After doing some literal equation, this is the formula for R. There. Okay. This is the formula for R in terms of arc and the central angle. Okay. All right. Remember, we have assigned these letters so that S is our arc, okay, and then R is our radius, and then our Q is our central angle, okay, and this must be in radians, okay, in radians. Yeah. Okay, it must be in radians. So S is equal to arc, R is for radius, Q is for central angle in radians. Okay, all right. Now the S and the R should be consistent with the units. If S is feet, then R must be in feet. Okay. If S is centimeters, then R must be centimeters. There. All right. Must be consistent in the units. So we're after R here, so it's S over Q. So if we continue, this will be R. Okay. Our S is given, that's 24 inches. So this will be 24 inches. There. Okay. This is divided by Q. All right, that would be 4 radians there. And the final answer will be 24 over 4. That will just be 6. And this will be, of course, 6 in inches. Okay, you can ignore the radians there. Okay, you can ignore the radians there. All right. So this will now be 6 inches. This will be the length of the radius. Okay. All right. So we can verify the answer. All right. Radius is equal to 6 inches over here. Okay. All right. That's the computer's answer. Here's our answer, of course. All right. So let's proceed to number 12. Let's continue with number 12. Okay. Let's have the next. Number 12 is over here. A circle has a radius of 12 feet and an arc of length 48 feet is made by the intersection of the circle with a central angle. What is the measure of the central angle theta? Okay. All right. Since we don't have the theta in our keyboard, we will just replace it with Q. All right. Just like in the number 11. All right. So let us write the given first. Let us have the given first here. Okay. We have radius. Radius is 12 feet. Okay. And what else? We have arc. We use S for the arc. And that's 48 feet also. Okay, we're looking for the angle, okay, and we shall use, instead of the Greek letter theta, we'll just use the Q, and this will be the unknown, okay, there, okay, and so we shall have our formula, okay, the formula is the same as what we did in number 11, Okay, this is S is equal to R times the angle. Okay, there, that's the formula. And we're after the angle here. And so after some literal equation, we have Q. This is equal to S over R. Okay, S over R. There. This is our formula. Here's our formula if we're asked to solve for the angle. Okay, there. Okay, all right. So we will proceed by using this formula. This is for the central angle Q, and we shall use S. That's 48. This is 48 feet divided by the radius, which is 12 feet. Very simple. Okay, there. Okay, so this will now be, of course, 48 over 12 is just 4. Okay, so this is Q. This is equal to 4. Now the unit here will be radians. Okay, okay, the unit of the angle here will be radians. There. There. So it's 4 radians. We can verify our answer. All right. Theta is equal to 4 radians. Okay. All right. And so that's it. Let's continue with number 13. Let's have number 13. Here's number 13 question. How long is the arc intersected by a central angle of pi over 3 radians in a circle with a radius of 18 centimeters? Round your answer to the nearest tenth. Use pi equals to 3.141592654. Okay, let us write the given first. And our requirement here is, all right, radius of 18. We're asked to get the arc. Okay, how long is the arc? Okay, we're after the S. Okay, all right, so let's start with enumerating the given first. Okay, what we have is central angle. Okay, we shall assign Q again. Okay, and this is pi over 3 radians. There. What else do we have? In a circle with a radius of 18 centimeters. So we have the R. Okay, R is equal to 18 centimeters. There. Okay, so we're after the arc S. We're looking for the arc there. Okay, so this must be in centimeters also. The unit of the radius and the subtended arc must be consistent with the units. All right, so we will start with the formula. Okay, the formula is S is equal to R times the angle. Yeah. Okay, this is our formula. All right, and so we shall begin with S is equal to R 18, okay, times our given angle is pi over 3, okay, that's pi over 3. So we have the pi and then over 3. There. And we shall continue the fraction there. There, okay. And so we have 18 times pi over 3. Now, you can see the 18 and the 3, okay, 18 is divisible by 3. So our answer here will just be 6 pi. Okay, so S is equal to 6 pi. Okay, 6 pi, and this will be, of course, in centimeters. There. Okay. Now the answer here can be computed with decimal numbers. So S is equal to 6 times the pi, the equivalent, we're asked to use the equivalent 3.141592654. and we're going to multiply this. Okay, all right, to get the final answer. So this will now be 6 times pi. That's equivalent to 18. Okay, the answer is over here. S is equal to 18.849555592. This is centimeters. All right, correct to 8 decimal places. We're asked to round your answer to the nearest tenth. So the 4 will not affect the 8 in 0.849 there. So that will remain 18.8. Okay. So S is equal to 18.8 centimeters. There, that's it. This must be our final answer. There. So this is the arc length. Okay. And let's see the answer. Do we have the answer there? Number 13 answer is over here. There. Arc S equals 18.8 centimeters. Okay, that goes with our number 13. So this must be the right answer. Okay, continue with the last number. Let's have the final number 14. Okay, here's number 14. All right. Do we have 15? No more. All right, so this is the last number 14. A circle has a central angle measuring pi over 6. Let's start with the given. Okay, let's start with the given. Okay, central angle, we use Q. And this is pi over 6. Pi over 6. And it's supposed to be radians. Okay, supposed to be radians. So the unit given is radians. Now, if the angle given is degrees, you have to convert that to radians. That's how it works in the formula. It's got to be an angle in a radian unit. Okay, if you use the formula. All right, so we have the central angle pi over 6 radians that intersects an arc length of 25 inches. So arc length S is equal to 25 inches. Yeah. Okay, what is the length of the radius of the circle? We're asked to find the radius R. There, okay? All right, so we're asked to find the R. Again, round your answer to the nearest tenth and use pi equal 3.141592654. Okay, so the same formula. We have S is equal to R times angle. We're after the R, okay? So we will manipulate the formula such that R is S over Q. R is equal to S over Q. There, S over Q, and this is our formula. This is our formula for finding the radius of the circle there, okay? All right, so R is S over Q. All right, so to continue, we will put the numbers. We have now R is equal to, let's put the arc. The arc is 25 inches. The angle is at the bottom, that's pi over 6. So this will be pi over 6 there. There, okay? And so we will have this like, after manipulating the fractions, this will become 150 over pi, okay? The 6 goes up, okay? The 6 goes up, so that will become 25 times 6 over pi. It will proceed to the numerator, okay? So this is something like 25 times 6, okay, over pi, like that, okay? That's how it will become, okay? There, okay? Because it's 25 divided by pi over 6. It's like that, okay? And so that will become 25 times 6 over pi. And this is also equivalent, using the value of pi now, this is now equivalent to 150, the product of 25 and 6, okay, divided by the equivalent of pi, which is 3.141592654. There. And this is division. So this is 150 divided by this number pi. Okay. All right. And so we get the final answer after we divide. Okay. All right. Let's divide 150. We divide this by the pi, and we get something like 47.746293. And the unit of this radius must also be consistent with the length of arc unit, which is inches. So this is inches. There. Now we're asked to round our answer to the nearest tenth. Okay, so 47.74648293. The number after the 7, okay, that's 0.74. So the 4 will not affect the 7, so this will remain 47.7. So this is 47.7, okay. And the unit is, of course, inches. All right. There. And that's our final answer over there. It's 47.7 inches. Okay, this goes to our number 14. And we can verify this for there. 47.7 inches, okay, as compared to the computer's answer over here. All right. This must be our correct answer. All right. That should be it for our 14 numbers. I hope you were able to learn radian to degree conversion, degree to radian, radians to degrees, and some problems about arcs, radius, and central angles of a circle. Okay, so see you later, and we'll be discussing more, okay, later. And so that be for today. So see you later.